The skill that will be covered here is geometric versus arithmetic sequences. Before we start writing and evaluating arithmetic and geometric sequences, we need to first discuss the difference between the two. Look at arithmetic sequences like a linear equation. That's when you add or subtract to get to the next value. Now, when you add or subtract, the amount that you're adding or subtracting, when it comes to a linear equation, that's called your slope. Arithmetic sequence, that's called your common difference. Your common difference is the same thing as your slope. How much are you changing by, adding or subtracting by? A geometric sequence is going to be an exponential equation. Notice that you only see multiply here. You don't see divide, because when you divide, you can multiply by a fraction that's going to give you that division. So like, for example, if you're dividing by 2, that's the same thing as multiplying by 1. So in review, an arithmetic sequence is when you add or subtract to get to the next value, which is a linear equation. A geometric sequence is when you multiply to get to the next value, which is going to be an exponential equation. Now, when you look at a sequence, you got to check to see if it's arithmetic, geometric. It could be neither though. So you got to make sure you check on both. So if you look here at this first example, look at how we checked it. To see if it's arithmetic, you take the second term minus the first, the third minus the second, as you can see here, and we don't get the same value. So that means it's not an arithmetic sequence. But once you take the second divided by the first and the third divided by the second, that's how you check to see if it's geometric. And once we do that here, we get the same value, which tells us that this is a geometric sequence. And that answer that we got, that 2, that's the common ratio. Now, if you look at the example at the bottom here, we did the arithmetic sequence check and notice that it checked out, which means it's an arithmetic sequence. So now your answer that you get for the arithmetic sequence is your slope or your common difference here. All right. So once you decide if arithmetic or geometric, you should already know the common difference or the common ratio. If you like, oh, it's geometric, whatever that common answer that you got is your common ratio. Oh, it's arithmetic, whatever that common answer that you got is your common difference, as you can see in the bottom example. And then here are a couple more examples. This is one of arithmetic where you might not be able to look and just eyeball it all the time. All right, it's common difference of negative 24. And then the bottom one is going to be a geometric with your common ratio of 0.25 or 1/4. Now, when you look at these last two, before we go into more detail with sequences, you could check it and it could be neither. This is why you need to do the arithmetic sequence check and the geometric sequence check. Don't just do one and assume the other. Because I get 6 and 9 and I get 3 and 2. Neither one of them checks out. So I don't have an arithmetic sequence or a geometric sequence. This is neither. But then you might look at this one at the bottom and say, oh, that's probably neither too though. Because we did arithmetic, geometric, it's probably neither as well. You have to check it. Because it's not an arithmetic sequence, as you can see from the check. But when I do the geometric sequence check, it comes out to 1.75. The answers are not always smooth. So please do not try to eyeball, that's arithmetic, that's geometric, that's neither. Go through the process. All right, so that's first deciding on if it's arithmetic or geometric. Now we're going to discuss how to write a recursive formula. These recursive formulas that you see pictured here are on your formula sheet. You do not have to memorize these. And when you see a sub n minus 1, that's just saying the previous term. And then the recursive formula is just going to give you enough information to find the next term. You can't hop to the 5th, 6th, 7th, or the 80th. You can take whatever term is given to you and find the next one. You can find them in order. The way you read this is, think about what's happening to the a sub n minus 1. I'm adding to it here, or subtracting, depending on what your common difference is. So that's an arithmetic sequence. This ratio, I'm multiplying by it. So if I'm multiplying by a sub n minus 1, that means it's a geometric sequence. If I'm adding or subtracting to a sub n minus 1, that means it's going to be an arithmetic sequence. All right. Now, oftentimes for arithmetic sequence, it'll be plus or minus on the back end. And oftentimes for geometric, it'll be the common ratio on the front end. But it doesn't have to be written this way. It could be written a sub n minus 1 times a number, and that's still going to be a geometric sequence. So just be careful with that. So if we look here, we did our arithmetic and geometric sequence check. So I know it's geometric. So, and I know my common ratio is 3 because when we do our check, we already know the common ratio or common difference depending on the sequence type. Now, when you write your recursive formula, This is the same thing as a sub n minus 1 times 3, like I stated earlier, but oftentimes you see it written like this. All right. So then we look at the example over here. We get an arithmetic sequence, which our common difference is 8 here. A positive 8, which means you're going to be adding. So then I have a sub n minus 1 plus 8. All right. And if you look here, to find our next terms, I know 20, then I had to add 8, get 28, add 8, and get 36. You can't skip terms when you have a recursive formula. You can do that when you get to explicit formula. You can just hop to a term. Now to go back to this one, because we didn't discuss the next two terms for this one. If I know this is 36, and I know my common ratio is 3, that common ratio is what I'm multiplying by. That's my multiplier. That's what I'm multiplying by to get to the next value. So I take 36 times 3, get 108, times 3 gives 324. So let's go ahead and do our arithmetic and geometric sequence check, as you can see here, and it's the arithmetic sequence, and it's negative 81, which means I'm subtracting by 81, as you can see here in the recursive formula. So if I want to find my next two terms, I take 259 minus 81 and minus 81 again. And when you look at the next example, you can see that it works out for our geometric sequence check, which means I'm going to be multiplying by 1/4. Notice that it's getting smaller and my multiplier is less than 1, between 0 and 1. All right, that's a common characteristic. So a sub n minus 1 times 1/4, or oftentimes you'll see it written in this format here. So if I want to find my next term, I take 48 times 1/4 and then multiply that answer by 1/4 as well to get to the fourth and the fifth terms. Now let's look at the explicit formulas. These formulas are also on your formula sheet. You do not have to memorize these. You just need to know how to use them. Now let's read through them. This is the arithmetic sequence explicit formula. This is the most important one because this is the one that can hop to any term that you need. All right, if you want to find that 80th term, you can hop right to the 80th. The recursive requires you to find every term in between the term that's given and the term that you're looking for. Explicit, you do not need that. So the way you read this, the first term, a sub 1, plus d, which is the common difference. So if your common difference is a positive 5, you put plus 5 here. If your common difference is a negative 3, you put minus 3 here. And then in parentheses, n minus 1. N represents the number in the sequence that you're looking for. So if I'm looking for the 80th term in the sequence, I replace n with 80. Now let's look at the explicit formula for the geometric sequence. If we already know that it's geometric, that means we already know the common ratio. So that's our base right here. A sub 1 is our first term. And then now you raise it to the exponent of n minus 1. So that's whatever term you're looking for. But make sure you put this in the exponent. And when you type in the decimals, I would do parentheses n minus 1, close parentheses. And then you replace n with whatever term in the sequence that you're looking for. All right, so once we do our arithmetic and geometric sequence check, we know that it's geometric. And our common ratio is 4. So when I write my equation, I know 4 goes here. My first term is 0.75. And then now, if I'm looking for my 15th term, I replace n with 15. So this is my explicit formula. When I place n with 15, that will be my final result right here. I know it's a very large number, but exponential functions grow slowly initially, but they really start to pick up on the back end. Now when we look at the next example, when we do our arithmetic and geometric sequence check, we realize that it's arithmetic. And our 9, which is going to be our common difference, which is our slope. So when you write the explicit formula, our first term is 311. And our common difference is a positive 9, so I put plus 9. And I do parentheses n minus 1. But notice that I have this one written as well. These are equivalent. If I took 9 times n, I get 9n. If I took 9 times negative 1, I get negative 9. 311 minus 9 gives you 302. These are equivalent. So if there's multiple choice and they're giving it to you in y equals mx plus b format, follow the slope. We know that the slope, which is a common difference, is going to be positive 9, so your slope needs to be 9. Now the other question is like, man, how do you know that the y-intercept is 302 and not 311? You can distribute this 9 throughout. Distribute this throughout, and once you simplify it, you should be able to get 302. Worst case scenario, you can plug in 1 for your first term, and you should get 311. You should plug in 2 for your second term, you should get 320, and so forth. Now, what's the 15th term? You can plug 15 into either one of them. I think I normally plug it into the top one just because there's no point in simplifying it if you don't have to. Actually, for the 15th term, you have to find the explicit in order to get to your answer. So you don't need to simplify it as well. You can just write the formula in explicit formula. So now let's look at the next examples. We did our arithmetic and geometric sequence check and realized that it's arithmetic and it has a common difference of negative 125. So like I stated earlier, this plus d here now is going to be negative 125 because your common difference is a negative here. And then it also can be written like this, but without even knowing what your simplified answer is or simplified equation is, we know it has to be negative 125n because that is my slope. And then if I take negative 125 times negative 1, I get a positive 125. Add that to 625 and I get 750. Now, if I want to find the 15th term, I just plug 15 in. But remember, if they ask you for the 15th term, you don't need to find the second equation. You can just use the explicit formula and type 15 right on in. All right. I just want to show you this just so you're aware that both of these are equivalent. So when we look at the next example, we do our arithmetic and geometric sequence check and we realize that it's going to be geometric, which our first term is 625. So we go ahead and place that out front. Then we know our common ratio is 4 over 5 or 0.8. Then now, if you want to find the 15th term, you just plug in 15. And you get 27.49.